Hello physics students. Today, me, Ian, and Matt will be doing our Theoretical Thursday on circuits and electricity in this household. Okay, so today we'll be exploring two different types of circuits. Series circuit and parallel circuit. Now I'd like you to focus your attention on these three lights right here. They're all attached to one wire that goes through the wall, and my lovely assistant Ian will now turn on the lights. Now you see the lights are on. Now we're going to test to see if these are series or parallel.
Alright, so to test the theory of these being parallel, we decided to unscrew this light bulb. Obviously I didn't do that because I'm crippled, but we had Ian do it because he's tall and yeah, Ian's over there. So Ian, could you turn the lights to see if this is parallel? Alright, so in this circumstance they are, but there's always a thought that this light bulb could be the final bulb in the circuit and that all these turn on but this one doesn't. So we're going to test this by unscrewing that light bulb and seeing if these two go out.
Okay, so we've confirmed that this circuit is a parallel circuit because, Bilal, turn on the lights. Because when we took this one out, these two stayed on. And now that we've taken this one out, these two stayed on. In both of these situations, if one of these bulbs had been out and it would have been a series circuit, both of the other bulbs would have come out. Thus confirming that households use parallel circuits and not series circuits.
Okay, here's the part we've all been waiting for, the math part. Okay, so first off, we have given from that the light bulb, here I'll write this down for you guys. Light bulb that we're using, 60 watts, which is the power, and the light bulb is 120 volts. Okay, so from the book, page 731, if you guys want to go along with us, we could find that electrical power is this equation, P equals IV, power equals current times voltage. And in this Theoretical Thursday, we are trying to find the current that runs through the light bulb. So then we would convert this equation to P over V equals I. Okay, so we just plug in this for P, this for V. 60 over 120 equals I. And then I need my calculator for this one because this one's a tough one. 60 divided by 120 equals 0.5. So this comes out to 0.5 amps. Okay, so since we all know that in a parallel circuit, the current that runs through each of the light bulbs are the same, we can assume that all the light bulbs are 0.5 amps. And this should make sense because this explains why in a parallel circuit all of the light bulbs have the same brightness.
In household circuits, it makes sense that the whole system is based off of a parallel circuit. Because if one light bulb were to go out in this entire room, we'd have to go to each individual light bulb to figure out which one was dysfunctional. Also, when we're talking about resistance, the resistance in a series is you add up all the individual resistance and then you find the total resistance. However, in parallel circuits, you take the reciprocal of 1 over all the resistances and then add it up. So it's a fraction of the resistance that would be in a series circuit.
Follow me, classmates.
Dun, 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 dun.
The moment you have all been waiting for. The conclusion. Parallel. Check my spelling on this one. Circuits greater than or equal to. No. Just greater than. Series circuits.